Yes, is this audible to you all? Atif, Fatima, Hamza, Huzaifa, Sarah.
Yes, teacher.
So in the last class, we had covered a few important topics, which included internal resistance of the cell, EMF of the cell, and the terminal potential of the cell. So internal resistance was what? Internal resistance was basically the resistance that was offered by the electrodes and the electrolytic solution. Then we had seen what was EMF. So EMF was the maximum potential difference across the terminals of cells in case of what? When there is an open circuit. And same thing goes if the circuit is closed, then that becomes what? Your terminal potential difference. So formula of current is what? This is I is equal to E divided by capital R plus small r. This is the value of current. Capital E divided by capital R plus small r means EMF of the cell divided by external resistor plus the internal resistor. And then we had seen the formula of terminal potential difference, that is I multiplied by capital R. So I multiplied by capital R is E divided by R plus R multiplied by R. Or another formula that you have is V is equal to E minus IR. So we had seen a question as well. In this, few points were left. 3 basic points were left. Firstly, if your cell is in this manner, this is your cell of EMF E. This is the internal resistor that is connected with the cell. And current is coming out of the battery from the positive terminal. This is the direction of current. In this direction, current is coming out from the cell. So here we use this equation. V is equal to E minus IR. E is the EMF of the cell, I is the current, R is the internal resistance of the cell. V is equal to E minus IR. Now, this is called discharging of cell. This phenomena, this is known as discharging of cell. Whenever we use this, no, or whenever you see this direction, that current is coming out of the cell, then you call it as discharging of cell. Contrary to this, if you have the cell connected and this is the internal resistor and current is coming out from the negative terminal, it seems that current is moving into the battery. This is EMF, this is internal resistor, this is the direction of current. Then we call it as charging of cell. This is known as charging of cell. So V in this case becomes E plus IR. If you see this direction of current, then simply instead of subtracting, use E plus IR. And the last point that I was mentioning you, this is if your key is open. If the key is open, then see current will be what? Current will be 0. Key is open, circuit is broken, so current will be 0. Now current is 0, in this substitute I is 0, in this or this, we will directly be equal to EMF of the cell. So these 3 points were left in this. Then we start with series and parallel combination of resistors. First note down these 3 points. And what about the assignment? Only Fatima has submitted the internal resistor one. I think only Fatima has. Fatima, you have submitted, no? Yes. Fatima has submitted. Only Fatima has given this assignment I'm talking about. Resistivity and resistance. Did you people receive internal resistance one?
Teacher, I'm currently having exams, so I was not able to complete. I'll try to
Okay,
submit it
okay.
by today.
All right. So you people are having your exams right now. Then after this, you will be having your summer vacation. Atif?
Yes.
Now, before moving on to separate combinations of series and parallel, if you have this circuit only, means cell with their internal resistors are connected. As in, this is, let's say this is the first cell with EMF E1, this is R1 resistor. Then this is E2 cell with its internal resistance as R2. Then this is E3 with its internal resistance as R3. And the external resistor is also connected in the circuit. So always remember, if you see all the directions of EMF are together, means positive terminal is connected to the negative, then positive is connected to the negative, positive to the negative in a synchronized order. If it is connected in this manner, see equivalent EMF. Equivalent EMF, E equivalent, this will be the sum of all the EMFs. E1 plus E2 plus E3. Even if more cells are connected with their EMF, then simply add them, E1 plus E2 plus E3 up till En. So this will be the equivalent EMF. Then equivalent resistance, equivalent internal resistance. This is basically the internal resistance. So R equivalent will be what? Sum of all the internal resistance. R1 plus R2 plus R3 and so on. This will be the equivalent resistance. Now all the formula will remain the same, what you have studied. It's just that you will be adding equivalent with them. The way you had currents formula, no, E divided by capital R plus small r. So here it becomes E equivalent by R plus R equivalent. Just add equivalent. So in equivalent, you have to first take the sum of all of them. All right, so we'll do a question also on this. First note it down, then we'll do a question also on this. See, current will be what? E equivalent. Did anybody get the answer? No one? Fatima? Atif?
Calculating.
Calculating. Sarah, your exam's over now. Yesterday you were not there in the class. Or is any paper left now?
I actually changed my batch.
Okay, okay. So current is E equivalent divided by capital R plus small r equivalent. So E equivalent will be what? Sum of all the EMFs that you have. So first is, this is 10 volt plus 5 volt plus 15 volt. So that makes it 30 volt. And small r equivalent will be what? 2 plus 2 plus 1. 2 plus 2 plus 1. This becomes 4, 5 ohm. And capital R you already have as 10. So just put in I will be what? Equivalent is 30. Capital R, this is 10 plus small r, this is 5. So 30 by 2, 30 by 15, that is 2 amps. Here is the answer. Second part says terminal potential difference. So current is 2 ampere. Terminal potential difference, you have a single formula for it. V is equal to E minus IR. Now, E for which cell you have to calculate terminal potential difference across 10 volt cell. So EMF that you will consider, that will also be 10 volt. So you will be writing, instead of E, you will be writing as 10 volt. Current is 2. Resistance is 1 ohm. So that is 10 minus 2, which is 8 volt. So voltage is 8. Now, one more thing in this. If somehow I reverse a battery, these were the 3 cells that were connected, 1, 2, 3. If I reverse any of them, let's say I've reversed middle one. This is the case now. This is the cell with the internal resistor. This I have reversed with its internal resistor, and this is connected in this order. And this is the external resistor connected. See, this is R1, this is R2, this is R3, EMF1, EMF2, EMF3. In case of EMFs, whenever you are writing equivalent, always check the direction. If all of them are in same order, if all of them means including nth number of cell. So if all of them are in the same order, then add directly. If any cell gets reversed, then definitely add a negative sign in front of it. Like in this manner. Yes, in this manner, E equivalent will be what? This and this one, both are having the same direction. Just take one direction as positive, other direction as negative. Let's say this is the positive one. So it becomes E1 minus E2 plus E3. And see, resistance can never be negative. So all the resistance will be what? Sum of all the resistors. That is, never reverse or add a negative sign in front of resistors, because resistance can never be negative. You can get a negative EMF in case of equivalent, but for resistors, resistance can never be negative. So R1 plus R2 plus R3, always take the sum of all the resistance. So this will be R1 plus R2 plus R3. And rest of the story will be the same. I is equal to E equivalent by capital R plus R equivalent. All right, so this was related to your terminal potential difference topic only, but a combination of cell comes if it comes in your exam. Now note down the solution of this question as well as this point that I have mentioned, and then we'll start with series and parallel combination. It will be similar to what you have studied in case of capacitors. This one, this, are you talking about this point, Sarah?
Yes, ma'am.
See, if the cell gets reversed, any of the cell reversed means if you can notice this cell, I have reversed this, means negative, this is connected, negative potential, negative terminal is connected to the negative terminal of the cell, and the positive terminal is connected to the positive terminal. Whereas in the previous case, what was happening? Negative was connected to the positive, then again negative was connected to the positive in a sequence. Now in this, negative terminal is connected to the negative terminal and positive terminal is connected to the positive terminal. So if any of the cell gets reversed, what you will do, add a negative sign in front of it, means E1 and E3 will be added, and E2, since it is reversed, you will subtract it from the total sum. If there are other cells also connected, so do one thing, just take this direction of the cell as positive and take this direction of the cell as negative. Either you can do in this manner or otherwise do in this. Simply whichever you see odd one, just add a negative sign and subtract it. Otherwise, what was happening? All the EMs were getting added. Here in this case, now EMF, whichever is reversed, the sign will also change. Clear? Let's say n number of resistors are connected in series. So in case of capacitance, which quantity remained the same in case of series? Which quantity remained the same in case of series? Charge or the potential? Yes. Hamza? Yes, right, Fatima. Hamza? Charge or potential? Which remained the same in case of series? Series connection and capacitors. We have done, no, Hamza? So charge or potential, either of them remained the same in case of series and the other one remained the same in case of parallel combination. So in series, which quantity remained the same? Was it charge or was it potential? Hamza, try to recall. Fatima, you announced the answer. What did you write? What's the answer, Fatima?
Charge.
Charge. Yes, Hamza, charge will remain the same in case of series combination. So as I've told you, everything gets replaced in terms of current in case of when you're talking about series combination. That's why we had done capacitors topic separately. So here current will remain the same. If the current remains the same and the voltage that divides. So it's the current that remains the same while voltage divides. So let's say I current is flowing. So I current will only keep on flowing through all the resistors that are connected. Let's take R equivalent. So R equivalent, here voltages will be different. If I want to know what is the sum of all the voltage, it will be V1 plus V2 up till n number of resistors are connected. So Vn will be the potential of it. V is equal to IR according to Ohm's law. If V is equal to IR, then this will be R equivalent, I1, R1, not I1 and all the resistors, these are same. So it will simply be I. This will be IR1 plus IR2 up till IRN. So all the current gets cancelled. R equivalent is basically R1 plus R2 and keep on adding it till Rn. This is the formula of resistors. Just recalling, in case of capacitors, series combination was what? 1 by C equivalent was equal to 1 by C1 plus 1 by C2 plus 1 by C3 up till 1 by Cn. In case of series combination, in case of resistors, the net resultant equivalent resistance is sum of all the resistance directly without taking the reciprocal of it. Now, if you are asked to write the current or you are asked to calculate the current through each of the capacitor, what is the current through each capacitor? Not capacitor, sorry, resistor. So current through each resistor. So I1 will be equal to I2, that is equal to I, because current will be the same across each, or you can write it as V divided by R equivalent. Whereas voltages will be different across each resistor. So you can be asked to write the voltage across each resistor. This will be IR1, V2 will equal to IR2 until Vn will be equal to IRN. This will be the formula. Across each, what is the total voltage of the circuit? That will be given to you. You can see and look whatever is the voltage that is given. Apart from this, power can also be asked to calculate. Power's formula is I square R. The formula of power dissipated. Power that is dissipated across each resistor. This power general formula is basically I square R. So if you are asked to write the power across first resistor or second resistor, you can calculate it in this way. P1 will be equal to, current will be the same, I square R1. Then P2, I square will still be the same, R2. Up till Pn will be I square Rn. Or if this is across each, if you are asked to write what is the power that is across the whole circuit, so power will, you can write it as I square multiplied by R equal. This is the form. So we'll also do a question on series combination. For that, first you write down all these points because all these will be utilized in the question that we'll discuss. So first write the series combination. Wherever, in whichever point you get stuck, just text me or simply ask me. I'll repeat it. Yes, Fatima's answer is right. See, R equivalent is very easy to calculate. Yes, Sarah, correct. Fatima, Sarah, try the second and the third part as well. Second part also you don't need to calculate that much. Yes, Sarah, second part is right. Hamza, R equivalent, correct. Good. Hamza's equivalent resistance is also correct. You also try Fatima Munir, your answer, R equivalent. Fatima, try the answer. First part at least. Hiba, answer from you also. Good, Atif. First, second part, all right. Calculate the current, all of you, rest of the students. Huzaifa, you also try. R equivalent is very easy, R1 plus R2. Current, Atif, correct. Current is right. At least till the third part, all of you should be able to calculate. Yes, Hiba, right. First answer is right by Hiba. Atif, if you have calculated the third part, then fourth part is very easy for you. Yes, Sarah, reduce it. Both the numbers can get cancelled. Try to reduce it further. Third part, yes, now it's right. Atif, fourth part is also correct. Fifth part, Atif, do the fifth part as well. Last part also. Then it will complete your question. Huzaifa, you didn't answer any part. R equivalent is coming what? Atif, V1, value of V2. Good, Atif. So Atif has tried all the parts. Fourth part, no, Sarah. See, current remains the same in series combination. So whatever value of current you are getting for the whole circuit, that will only be the value for each. And Fatima, where did you get stuck? After R equivalent, rest of the answers also, Fatima. Okay, let's discuss it. See, R equivalent, this is simply R1 plus R2. In series combination, you directly add them. So this will be what? 5 plus 10, just add them. That will be 15 ohms. 5 plus 10, this is 15 ohms. Total voltage is given to you. Total voltage across this whole circuit, this is already given to you. You don't even need to calculate it. Voltage is 10 volt across the whole circuit. When it asks you the total voltage, then look at what is the total voltage given in the circuit. If it asks you voltage across each, then you have to solve and do the calculation the way it is given in the fifth part. Then it is asking us to calculate the total current in the circuit. If you know the total voltage, if you know the total resistance, with the help of V is equal to IR, you can easily calculate the total current in the circuit. So R equivalent, R equivalent is what? R equivalent is basically total resistance. So third part, V is equal to IR. Here you have to use R equivalent. Fifth part is right. Sarah, fifth part is right. Correct. Just there's an error in your fourth part. Just check your fourth part. The rest of the parts are correct, Sarah. So V is what? 10 volt. Current is this. R equivalent came out to be 15. So current will become 2 by 3 amperes. Now, what is the fourth part saying? Fourth part is saying current in each. See, current through the resistors in case of series combination remains the same. It means if I current is flowing through 5 ohm, then I current will only be flowing through 10 ohms. So if 2 by 3 amperes is flowing in the whole circuit, it means 2 by 3 amperes will be going through 5 ohm as well as to 10 ohms. So this becomes what? The answer for the fourth part, I1 is equal to I2, which is equal to I ultimately, 2 by 3 amperes. And the fifth part, voltage across each. V1 will be IR1, V2 will be IR2. Here you had to put in the formulas. So V1 will be what? Current is 2 by 3. Resistance 1 is 5. So this becomes 10 by 3 volts. This is V1. This is 2 by 3 multiplied by 10. So this is 20 by 3 volt. This is V1. This is V2. All right. So just note down this and we'll do same things for the parallel connection.
Teacher, I have to leave because I have to go to another class.
Okay, Fatima. All right. Fatima, if the timing issue clashes, then you can join that batch where the time suited you. If your classes, both the classes are clashing, those classes which you join and these Learnivio classes, then just let us know. We can change your batch if you're preferring the other time. All right,
Teacher,
Fatima.
what is the other time?
One is your 4 o'clock time, which you are joining. Other one will be then 6:30.
6:30 also I will be outside only. Yeah.
On Tuesdays, you are not available.
Yeah, only Tuesdays.
Only Tuesdays. No, so you can join Monday, Wednesday batch.
Monday, Wednesday I have chemistry.
Okay, you have chemistry. All right, Fatma, we'll see. Then I'll talk to sir about this also. Okay, you right now you can leave. We'll be discussing parallel combination. Okay. Now, let's say n number of resistors, these are connected in parallel, R1, R2, Rn. Now, current will be different because parallel combination, current divides. Why? Current divides on branching, the way charge got divided on branching. So, current divides on branching. In case of parallel combination, current divides and the potential remains the same. Potential remains the same. Now, calculation, we will be all the same. All the potential will be the same. So, current will be different. Current in the whole circuit, this will be different. Means I will be equal to I1 plus I2 plus up till all the current of I1. So, V is equal to IR. So, R is what? V by R means V by R equivalent. We cannot write V1 because all the potentials are same. So, it will be V by R1 plus V by R2 up till V by Rn. So this is similar to series combination of capacitors where capacitors were 1 by R equivalent. So all the potentials get cancelled. 1 by R equivalent is reciprocal sum of all of the resistors, individual resistors up till 1 by Rn. This will be the equivalent resistance. Then the individual quantities that are present, current that is calculated through each resistor, it will be I1 will be equal to V by R1, I2 will be equal to V by R2, then IN will be equal to V by Rn. Here potential will be the same, resistor will be the different. So note down this point, we'll do a question and wrap up parallel combination as well. Let's note down this point, then we'll do a question on this. One or two cases we'll do and then I'll wrap up the class. But as you people get time, do submit the older assignments. Resistivity 1, internal resistance 1. I will not be giving you new assignment today. Just try to complete your previous assignments. Or this is for all of the students. Only one student from your batch, the one who has left, Fatima, only she has submitted. So others also, please try to submit your assignments. And if you're not receiving them, then also let me know whichever assignment you have not received. The last one was internal resistance, EMF and potential difference one, and before that it was resistance and resistivity one, both of them. Atif, your answer is right. Sara, that is 1 by R equivalent. You have to tell R equivalent. Yes, now it's correct. Second one's right. Second one will be this. Second one will be the same as the previous one. Find out the total current. Total current, okay, that is also correct. All right, all the parts are correct. Atif. Okay. Fifth and this. Okay. Sara's fourth part is voltage, no? Yes, right. Hamza, correct. First is correct. You can even leave it in terms of fraction, but right, your answer is right in terms of decimal. Second is also right. Third is also correct, Hamza. What about Huzefa? Huzefa, try this question at least. Previous question you didn't do. Huzefa, Fatima, Hiba. Hamza, try the fourth part now. There's some error in your first part, Hiba. Second one is right. Fifth part, Sara, current. Yes, both the current are right. Correct. So Sara and Atif, both of them have given the answer of all the parts. What about you, Huzefa? Are you there in the class? At least try the first part, R equivalent. Third is correct, Hiba. Third is right. Only there's error in your first part. Let's discuss it then. So R1 is given to you what? R1 is given to you as 5 ohms. R2 is given as 10 ohms. See how we solve this. If it is in terms of reciprocal, no, you cannot directly add them in the denominator. You have to take the LCM till the time both the denominators are same. So I think Hiba, there you must have committed error. 1 by R equivalent is what? 1 by 5 plus 1 by 10. Here you have to take the LCM. 10 will be the LCM. So this gets multiplied by 2 and this is 1. So this becomes 3 by 10. And this is 1 by R equivalent. You have to submit your answer as R equivalent. So this will be reciprocal of it. 10 by 3 ohms. Huzefa, did you understand now? Huzefa Ahmed? Then the second part says what? Voltage. Voltage across each. Okay, Huzefa. Fourth part, and the fourth part was what? Voltage across each. And the fifth part. Good, Hamza. Very well. Then the second part is total voltage. Total voltage of the circuit is given to you. V is equal to 10 volt. Third part was what? Current. Yes, third part was current. So current will be what? This will be simply V divided by R equivalent. V is 10, R equivalent is 10 by 3. So 10 gets cancelled, current becomes 3 ampere. This is the answer of third part. Now voltage across each and current across each, I think. Yes, voltage across each and current across each. See, Heba, did you understand how to solve the first part? We cannot add 5 and 10 in the denominator and write it as 1 by 15. You have to take the LCM and then solve it. Heba, just let me know if you have understood or not. Then fourth part was what? Voltage across each. No, so voltage will be the same because this is parallel combination. No need to calculate. 10 volt will be there, but current across each will be different. I1 will be V1 by R1. V means V will be the same. I2 will be V by R2. So V is what? V is 10. R1 was what? R1 was 5. So it is 2 ampere. This is I1 is 2 ampere. I2 will be what? V was 10 and it was 10 ampere. So it is 1 ampere. So I1 is 2 ampere, I2 is 1 ampere. You can add and check 2 ampere plus 1 ampere is giving you 3 amperes. That is giving us the total current of the circuit back. So all those who have not written it, just note it down. See, first these two resistors, these are divided on by branching because different wire is there. So both of these are connected in parallel. Now, whenever you have parallel case and both the resistors have the same value, simply take it as R by 2. Means this net equivalent resistance of this will become R by 2. You can solve it also and check, but it's a shortcut way to remember. If R resistances, both the resistances have the same value, then just take R by 2. Like if it was given 10 ohm and 10 ohm, so the net equivalent resistance will be 5. So this is the circuit that is now left. Now, A and B, you have to calculate equivalent resistance across A and B. R by 2, both of these are connected in what? Series. So, R1 will be, this was R1, this is let's say 2, this is 3, 4, 5, 6. So, R12 is R by 2. R12, this is R by 2. Then R123, R123. This is R plus R by 2. Why? Because both of them are connected by the same wire. So it will be series connection. So R1, 2, 3 will be what? 2R plus R, 3R divided by 2. Now R1, 2, 3, this is connected in parallel with this. How? You can see. This is the circuit. This is R, R, R. And now you have 3R by 2. So see, 3R by 2 and capital R, both of these are different. So you cannot write it as half of it. So you have to ultimately solve this. Both of these are connected in which manner? Parallel. This was fourth, no? Fourth, fifth, sixth. So fourth, R4 and R1, 2, 3, these are connected in parallel. So 1 by R1, 2, 3, 4 will be what? 1 by R4 plus 1 by R1, 2, 3. So R4 is what? R4 is capital R. So 1 by R1, 2, 3, 4 will be 1 by R plus 2 by 3R. So we have to multiply this by 3. It becomes 5. 5 by 3R. So R equivalent will be not R equivalent. R1, 2, 3, 4. Will be what? 3R by 5 ohms. Now all the three which are left now, these are connected in series, all the three of them. Just a second. So this was what? This was R. This is also R. And this that we have got, this is 3R by 5. So we can see all the three of them. These are connected in series now. So this becomes what? R equivalent will be simply adding all of them. These three are connected in what? Series. Reason? They are connected by a single wire. No branching is there. So current remains the same. And if current remains the same, then all the three are connected in series. So R equivalent will be what? R plus 3R by 5. So 5 will be taken as the LCM. It will be 5R plus 5R plus 3R. So 10 and 13. So R equivalent is what? 13 by 5R. This much is the equivalent resistance. So start noting it down. Try to solve it on your own. Wherever you get stuck, look it on the screen. And if you're not able to understand series or parallel combination in here, or whatever is the step you're not able to understand, just ask me. As you complete this, just text me done in the chat box. All right, Sarah, what about others? Still doing? Okay, Hamza, and what about Fatima, Atif, Hiba, and Huzefa?
Well done, teacher.
Done?
Yes.
Others as well? Fatima, Hiba, Huzefa? If you all are done, then I'm not moving further because many of you are having your exams now. So I'm not even giving you assignments further. Do complete your previous assignments and then submit it so that we can discuss it in the next week. Not next week, means on Tuesday. One more thing, you have a test on capacitance. Will you be able to give the test on Thursday on the topic capacitance or next Tuesday? Tell me according to your exams. You have to give a short subjective test in the class only, within the class itself. So is Thursday fine for you all? Thursday means day after tomorrow, whenever you have the next class. Others also respond, only Hamza has given his answer. If not Thursday because of your exam, then I can postpone it to Tuesday as well. Let me know whatever is according to your convenience, whatever is your exam.
The capacitance, right?
Only capacitance, subjective test. 2 to 3 questions will be there within the class itself. I'll conduct. The way we had a test on potential. So now we'll be having a test on capacitance.
Okay, teacher. Thursday is fine.
Thursday is fine by all of you? No issues? Thursday, Sarah. Thursday. Hamza has also agreed. Okay, then it is Thursday. Thursday, you have your subject.